Did you know that some of Asia's most fascinating beaches are hundreds of miles from any ocean? These landlocked shores tell an incredible story of wind, sand, and time. Deep in the heart of Central Asia, massive lakes like the Aral Sea have created remarkable beach systems that rival coastal shores. As powerful winds sweep across vast distances, they carry countless sand particles through a process called aeolian transport, gradually building up stunning beach formations along these inland water bodies. These windborne grains have been shaping the landscape for thousands of years, creating rippling dunes and sandy shores that stretch for miles. The most fascinating part, these inland beaches support unique ecosystems perfectly adapted to this harsh environment. Desert plants anchor themselves in the sand, while specialized insects and small mammals have evolved to thrive in these unusual habitats. But there's a dark side to this natural wonder. As the Aral Sea continues to shrink due to human water diversion, these beach systems are expanding into vast salt deserts, dramatically altering both wildlife patterns and local communities' way of life. The swirling dance of wind and sand continues to sculpt these remote shores, proving that nature's beach-building power isn't limited to ocean coastlines. What other surprising geological wonders might be hiding in Earth's most unexpected places? Did you know that in the frigid Arctic waters, there exists a geological wonder that scientists once thought impossible? These rare Arctic atolls are defying everything we understood about tropical reef formations. Picture massive rings of rock rising from the icy seas, shaped by a fascinating chemical dance between water and stone. Unlike their tropical cousins, these Arctic atolls face brutal weathering conditions that should destroy them, yet they persist. The secret lies in the unique interaction between freezing seawater and calcium-rich rocks, creating an extraordinary resistance to erosion. As Arctic waters sweep across these structures, they trigger a complex geochemical reaction that actually strengthens certain parts of the rock formation. What's truly remarkable is how these atolls serve as natural laboratories for studying climate change. Scientists have discovered that these formations hold detailed records of past Arctic conditions within their chemical makeup. The specific way seawater dissolves and reshapes these calcareous rocks creates distinct patterns that reveal centuries of climate history. Each layer tells a story of temperature changes, ocean chemistry, and atmospheric conditions from ages past. These resilient Arctic structures are fundamentally changing our understanding of how coastal formations adapt to extreme environments. What other secrets might these frozen atolls be hiding beneath their weather-beaten surfaces? Share your thoughts below, and let's explore this Arctic mystery together. Did you know that ancient glaciers left behind hidden treasures along South Asia's coast? These aren't gold or jewels, but something even more fascinating: mysterious ponds that tell Earth's icy history. Imagine massive ice blocks, left behind by retreating glaciers thousands of years ago, slowly melting into the ground. As these frozen giants disappeared, they created deep depressions in the earth, which eventually filled with water. These unique formations, called kettle ponds, dot the coastal landscapes of South Asia like nature's own fingerprints. Geophysical studies have revealed that these ponds aren't just random water bodies, they're perfectly preserved, evidence of Earth's glacial past, some reaching depths of over 100 feet. What's truly remarkable is how these glacial remnants have transformed into thriving ecosystems. Today, these kettle ponds support diverse wildlife communities and provide essential freshwater resources to coastal regions. The unique chemistry of these ponds, influenced by their glacial origins, creates perfect conditions for rare aquatic species found nowhere else in the world. Scientists have discovered that these ponds also play a crucial role in regulating local groundwater systems and protecting coastal areas from saltwater intrusion. What other secrets might these ancient ice footprints hold about Earth's climate history? Share your thoughts below and follow for more fascinating geological discoveries. Did you know that one of Africa's largest lakes has almost disappeared? Lake Chad was once the size of Maryland, but today it's shrunk to just 1/10 of its former glory. Nestled in the heart of the Sahel region, Lake Chad was a lifeline for millions, stretching across 4 countries and supporting countless species. In the 1960s, its vast waters covered an impressive 25,000 square kilometers, but dramatic changes were about to unfold. As global climate patterns shifted and regional rainfall decreased, the lake began its remarkable transformation. Year after year, its shorelines receded, leaving behind a patchwork of wetlands and dried lake bed. The lake's shrinkage reveals a fascinating story of geomorphological change. Satellite imagery shows how ancient dunes, once submerged, have resurfaced as the waters retreated. This transformation has exposed evidence of historical sea level fluctuations dating back thousands of years. offering scientists a unique window into Earth's past climate cycles. Today, Lake Chad spans merely 2.5 square kilometers, its waters fragmented into smaller pools and marshlands. This dramatic reduction has created a natural laboratory for studying how water bodies respond to environmental changes, showing us in real time how landscapes can transform within a single human lifetime. What other ancient secrets might be hidden beneath the world's shrinking lakes and seas? Did you know that earthquakes in the Middle East's steppes don't just shake the ground, they're secretly crafting new homes for countless species? These tremors are nature's architects of life. In the vast steppes of the Middle East, a fascinating dance between geology and biology unfolds daily. As tectonic plates shift beneath the surface, they create an ever-changing landscape of microhabitats, small, unique pockets where life thrives in unexpected ways. These geological movements crack open new water sources, form protective rock shelters, and reshape the terrain, giving birth to diverse ecological niches. Recent studies have shown that areas with higher tectonic activity host up to 30% more plant species compared to stable regions. What's truly remarkable is how these geological disruptions become catalysts for evolution. When earthquakes alter the landscape, they force species to adapt or migrate, creating a dynamic pattern of biodiversity. The relationship is so intricate that scientists can now predict biodiversity hotspots by studying fault lines and seismic activity patterns. These natural laboratories demonstrate nature's resilience, as species quickly colonize newly formed habitats within just a few years after major seismic events. What hidden ecosystems might be forming right beneath our feet at this very moment? Share your thoughts on how geological forces shape life in your region.